Okay guys, quickly going to run through questions 1, 2, 4, 5 and hopefully 15 just to give you a quick insight of what's going on. Now, what you'll notice about these graphs, y squared equals minus 4x plus 3, okay? It's a U-shaped curve, okay? And you know that by drawing the graphs in the drawn graph section, okay? You know that this is a U-shaped curve. Now, it's a U-shaped curve because it's a plus x squared. If it was a minus x squared, it'll be an n-shaped curve. Okay, this means it has a local minimum. It means it has a minimum turning point. So when you're on your way down, you're said to be decreasing, and when you're on your way up, you're said to be increasing. However, when you're going directly across at the local minimum, you're said to be neither increasing nor decreasing. Basically, your slope is equal to 0. Now, if your slope is equal to 0, this means your first derivative is equal to 0 at this point. So what we do is we differentiate the function y equals x squared minus 4x plus 3. When you differentiate it, what you should get is 2x minus 4. Okay, and you know your slope's equal to 0, so this means the first derivative is equal to 0. Move it over the other side, you get 2x equals 4. And then you do 4 divided by 2, and this gives you an x value of 2. Now the problem is you're looking for the coordinates, so you're looking for the x value and you're looking for the y value. To get the y value, you simply go back to your original equation and replace x with 2. Put that into the calculator, you get 4 minus 8, which is minus 4. Minus 4 plus 3 is minus 1. This means this minimum point must be the point 2 minus 1. Okay, so that's for question 1. Now we're going to move on to question 2. Once again, question 2 is also a U-shaped curve, so we can pretty much use what we did last time. I don't know where it crossed the axis, so this curve could be like, it could be, sorry, this that was the old curve. Imagine the new curve in blue. The new curve in blue could be over this side. It could be above the axis where it doesn't hit the line. Okay, you just don't know. So we're going to figure out what is the turning point, okay, of question 2. So to figure out the turning point of question 2, we do the same thing. At the turning point, the slope is equal to 0. This means the first derivative must equal 0. So we get this here, and then we get the y dx equals 2x plus 6 equal to 0. Then we solve for x, so we get 2x equals minus 6 when we bring the plus 6 over the side, and we get x equals minus 3. Okay. So we know the x value equals minus 3. Now we have to find out what the y value is. So the y value is use your original equation, but replace x with minus 3 to find out what the y value is. So we put a minus 3 here, minus 3 here, and we get 9 minus 18 plus 1. Then we get minus 8. So we know that this point is minus 3 minus 8. So that is your minimum turning point. Okay, so that's 1 and 2 done. Now we do question 5. Question 5 is an n-shaped curve. And the reason I know this is an n-shaped curve is because it has a minus x squared. So it could be an n-shaped curve over here, or the end could be over here. I don't really know, but it doesn't really affect what I'm going to do. What I know at the very top is that the slope goes straight across, so slope equals 0. This means the first derivative has to equal 0 as well. Differentiate 5, I get 0. Differentiate 4x, I get minus 4. Differentiate minus x squared, bring the 2 to the front, so I get minus 2x. I know that the first derivative has to equal 0. So essentially minus 4 minus 2x equals 0. I'm going to bring the 2x to the left, or to the right, just for clarity's sake. I can spin that around, 2x equals minus 4. And then divide minus 4 by 2, and I get x equals minus 2. Okay, now once I know that x equals minus 2, I next have to calculate what the y value is. So I'll go to the original equation, which is above here. I put down y equals 5 minus 4 times bracket minus bracket squared. So I need to put in the minus 2 there. Probably use the calculator on this one, getting a bit tired. Minus 4 times minus 2. And then minus bracket minus 2 squared. And we get 9. So this has a maximum point, because it's an n-shaped curve, it's a max, not a min, of minus 2, 9. Okay, guys. I'm going to move on to the next question, which is 15. So we got 1, 2, 4, sorry, 1, 2, 5, and now 15. Now 15 is a cubic equation, which means it has two turning points. It has a max and it has a min. Please remember that the max has the bigger y value and the min has the smaller y value. And both of them have a slope of 0. So what we're going to do is we're going to get the first derivative, 2x cubed plus 15x squared plus 24x minus 6. Now, you could always have we won't do that just yet, because you have to show your working. So the y dx is bring the 3 to the front. 3 times 2 is 6. Take 1 away from the power, 6x squared. Bring 2 to the front. Take 1 away from the power, 30x. And then differentiate 24 just to get 24. And then equals 0. Now you guys can do the minus b formula here if you want, or you can try factorizing it. It's your call. So you can divide all sides by 6, so you get x squared plus 5x plus 4. And look, if you factorize that, two numbers that multiply to make 4, but add to make 5, you're going to get plus 1 and plus 4. And then you know your x values are going to be x plus 1 equals 0, which means x equals minus 1. And then x plus 4 equals 0, and then x equals minus 4. Now here's a little trick you can use here. You can go to your table function, mode table function, and then you get 2 alpha x cubed plus 15x squared plus 24x minus 6. Now you can start at, see the way it starts at minus, so you can start sort of like minus 5 and go all the, sorry, we need minus 4, so start at minus 5 and end at, I don't know, 5, and have a look. Now you can see the minimum point is going to be, sorry, the maximum point is going to be minus 4, 10, so hopefully it'll work out, and the minimum point is going to be minus 1, minus 17. Now let's check that out using the original value. So it's 2 times something cubed plus 15 times something squared. So we're going to find the y values for the two x values. Okay, so you're going to have to do this twice. Best to show your workings. Don't just take it down from the calculator, because you might lose some of your marks for doing that. So what we get is minus 1, minus 1, minus 1, and minus 16. So this one is going to be minus 2. This one's going to be plus 15. This one's going to be minus 24. And that one's going to be minus 16. So I'm thinking what I'm getting here is that's minus 40. Minus 27 is what that one is. So the answer is for the, I think it's for the minimum, it's going to be minus 1, minus 27. And let's see if that checks out with the calculator. Oh, minus 1, minus 17. Give me a second. Maybe it went wrong there. Sorry guys, what I did there was it was actually minus 6, not minus 16. So that's where that little error came in. It's good to have the calculator as a backup, because then you can obviously see if you made any errors straight away. So that's why you do that in an exam. You have a calculator, it can give you the answer, and then you just have to make sure you get to that answer. Okay, the next one is going to be minus 4, which is a much more difficult proposition for me. I'm going to have to use the calculator for that. There's no way around that. So the answer should be 10, but we have to obviously make sure it is 10. 2 times minus 4 cubed plus 15 times minus 4 squared plus 24 times minus 4, and then take away the 6, 10. So that is our turning point. Our turning point is the point, what's it, minus 4, 10. Okay, and that's it done.